Hey mathletes, in this lesson we're going to look at a rigid transformation called reflections. So a reflection is just what it sounds like. You have a line of reflection as basically a mirror. You take each coordinate, you move perpendicularly, that's 90 degrees, to the line of reflection, and whatever the distance you move to the line, you move the same distance past the line. So A is 1, 2, 3 spaces from the line of reflection. So you go 1, 2, 3 spaces past it, and this is A prime. B, see B is 5 spaces to the line of reflection, so we go 5 spaces past it, and this is B prime. Point D is 1, 2, 3, 4 spaces to the line, so we go 1, 2, 3, 4 spaces past, and there's D prime. We see that point C is 6 spaces to the line, so 6 spaces past, and we have all 4 of our points. So we connect the vertices, and we have our new shape. You'll see that you can tell a reflection because it looks exactly the same as the other one, but it will be pointed in a different direction. See, we have DC pointed down and to the right, so D prime C prime is pointed down and to the left. Now reflecting over the X and Y axis is even simpler, because if we reflect over the Y axis here, you'll see that the Y number won't change. The X number will just flip signs, go from +1 to -1. Same with reflecting over the X axis. The X number won't change, it's just the Y number will go from -2 to +2. Not all lines of reflection are vertical or horizontal. That's okay, they can be diagonal. If you're going to go perpendicularly to the line, you need to know what perpendicular means. So a perpendicular line just has the opposite inverse slope. So we can see that this line has a slope of -1, which means the perpendicular line will have a slope of +1. So in this case, I'm reflecting along this line that has a slope of +1. I'm 1, 2, 3 spaces from the line of reflection. So 1, 2, 3 spaces along that same line will give me A prime. So B is 7 spaces away, so we're just going to go 7 spaces down and get to B prime. So point C is 6 spaces, so we're just going to go 6 spaces along our line and get to C prime. Then we have our reflected triangle. It does help to draw these perpendicular lines to your line of reflection, especially if the line of reflection is on a diagonal. So the last thing we want to be able to do is actually find that line of reflection if we have our two shapes. So the first thing you want to do is, if you don't have them, draw in your lines connecting your vertices. Then simply find the center of that line. So from A to A prime, this is 6 diagonal spaces. So we're just going to go 1, 2, 3 diagonal spaces and put a coordinate. So from B to B prime, that was 14 spaces. So we're going to count 7 diagonal spaces and put another coordinate. You really only need 2 to find a line equation. We're just going to do all 3 because we have them. So C to C prime is 12. We're just going to put a coordinate halfway in between. Then draw our line. So we're going to write this equation in slope-intercept form. So we can see the y-intercept of this line would be here at +3. So I'm going to put a +3 here. And I can see that between the two coordinates I've got a rise of -2 and a run of 2. So -2 over 2 gives me a slope of -1. And we don't need to put the -1 as a coefficient of x. You can just put a negative sign. So y equals -x plus 3 would be our line of reflection.